I am Sudhakar, Center for Cognitive Computing at IIIT Lahabaad. My project looks at the multifractal pattern of global brain coordination during the emotional experience. It is shown repeatedly in the literature that during the resting state, brain activity shows monofractal behavior. It means there is homogeneity in the irregularity of the response series. For instance, Ville et al. Showed that from 256 milliseconds to 16 seconds, the microstate embedding sequence follows a power law. On the contrary, when the participants are required to adapt to the environment during the executive control motor task, the brain activity pattern shows multifractal behavior as shown by RSEC recently. However, no such study has been done for emotional experience. An emotional experience which is situated in the context needs the adaptation of the situational context. Moreover, in our earlier study, we observed that the functional connectivity patterns for different emotion groups are different in the upper beta band, and the temporal variability of dynamic functional connectivity is related to emotional arousal and emotional dominance. Our earlier results led to the question that could there be any pattern to the temporal reorganization of brain networks or coordination between different brain regions during emotional experience, or is it a random process? Given the evidence of multifractality during adaptation-based behavior, we hypothesized that during the emotional experience, we might observe the multifractality pattern. To investigate this, we performed the experiment with an innovative idea to capture the emotional event while subjects were watching the emotional videos. Participants were asked to perform a mouse click whenever they felt any emotion. All the clicks, which we termed emotional events, were assigned an emotional category. Participants rated their emotions into 24 emotional categories with uneven distribution. Hence, we grouped some emotional categories to get an approximately equal number of observations per emotional group. The duration of each emotional event is 7 seconds, 6 seconds before the click and 1 second after the mouse click. Since we were investigating the temporal pattern in the global coordination of brain activity, we calculated the microstates using the EEG topo maps on GFP peaks. The microstates were selected using the cross-validation criteria. These microstates were backfitted and each timestamp was assigned a label of the nearest microstate. The microstate sequence was grouped into two groups. One of the groups was assigned +1 and another -1. Then cumulative random walk is performed to get the embedding sequence. The embedding sequence was used to perform leader wavelet-based multifractal analysis. Microstates are globally synchronized states which stays for 80 to 150 milliseconds before transitioning to another microstate. The idea was first observed by Lehman et al. They observed that if the polarity is ignored, the global brain activity stays stable for about 80 to 150 milliseconds. Since then, microstates have been used in several studies and sometimes regarded as the basic building blocks of spontaneous mental processes. The microstate calculation was performed for each emotion group. We observed a set of microstates for each emotion group. The global organization of each microstate is mentioned in the table. Primarily, microstates were organized in the anterior posterior, posterior max, central posterior, central minimum, frontocentral, left frontotemporal-parietal, right frontotemporal-parietal, and the diagonal organization. After backfitting the microstates, we observed these sequences. From the original sequence, we derived two more sequences. In one sequence in the middle, we tampered with the temporal pattern in the sequence. In another sequence on the right, we preserved the temporal information and only suffered the labeling. For the original as well as derived sequence, we calculated the embedding sequence. Then the leader wavelet-based multifractal calculation is performed on these embedding sequences. The diagram in the top corner shows the multifractality spectrum for different emotional groups. The x-axis shows the range of Holder exponents and the y-axis shows the Hausdorff dimension. Red, green and blue correspond to the original sequence, time-tempered sequence and label-shuffled sequence. In the diagram on the bottom right corner, the scaling exponent on the y-axis is drawn against the movements on the x-axis. For the green signal in which temporal information is tempered, the value of the Holder exponent is around 0.5 in all the emotional cases with narrow spectrum width. On the other hand, for the original signal, the Holder exponent with the highest density is around 0.75. We also observed the range of Holder exponents for different emotion groups as shown in the table. The table also shows the different spectrum widths for different emotion groups. The left truncated multifractal spectrum demonstrates the dominance of small fluctuations in the embedding sequence. These results are also cross-verified in the diagram in the bottom right. A bend in the straight line is the signature of multifractality, which is evident for the original and label shuffled sequence. We interpret that the range of order exponents in the multifractal spectrum summarizes the temporal change in regularity in the response series, which arises from the coordination between its temporal scales. Specifically, the width of the MS quantifies the influence of the multiplicative interaction or coordination between the multiple time scales. The coordination or interaction between multiple temporal scales facilitates the emergent change in behavior to adapt to changes in the environment, which is reflected in the inhomogeneously distributed variability within the response series. In the case of emotional processing, the coordination or interaction between multiple temporal scales might facilitate the continuous adaptation to physiological changes within the body, which is related to arousal, and coping with the external environment, which is related to dominance. Again, I am Sudhakar Mishra. These are my supervisors who have guided me in the project. These are lab members who helped in the experiment. The funding support was from my institute, IIIT Allahabad. Please reach out to me if you have any questions or comments about the project.